classes where I forget to do that. I did talk with them again about the heat. They said they probably won't be in here until next week to do something about it. So hopefully things will get better then. Until then, we have to endure. So we're going to pick up from where we left off earlier this morning, talking about how to do things in C++. So the first thing, and probably the most important thing, is how do you write comments, right? Everyone writes comments, right? Those are the things that explain how your code works so that when you come back the next day, you have some idea of what you did. Because I know I've definitely had times where I came back the next day, had no idea what I did, thought what I did was wrong, erased what I did, tried to fix it to make the right thing, realized what I originally had was the correct thing, and then changed it all back after wasting an hour, right? So definitely important to put in there, not only for reminders for yourself, but reminders for other people, like what's supposed to be happening. It's much better to explain like why you're doing something than what is happening, right? Those comments tend to be a lot more helpful. The what only tends to be helpful if what you're doing is very complicated. So in Python, you can only do single line comments, right? You start them with a hashtag, and then whatever comes after is ignored by the interpreter. In C++, we can do both single line and multi-line comments. Single line comments start with a // Everything after that // is treated as a comment. For a multi-line comment, anything enclosed between /* and / will be considered a comment. And that // can be on a different line. So you can see here's some examples of comments in Python. And then here's examples of some comments in C. And you can see that with the /* comment, you can even put a comment in the middle of some expression. I'm not sure why you would want to do that, but you could. And it'll work. Probably makes things look really confusing if you have something like that. Any questions about comments? Okay. So pretty much all of the arithmetic operators transfer over from Python directly to C, except not all of them. Addition, subtraction, multiplication are all the same. The things that are a little bit different are there is no exponentiation as an operator in C++. There is a function you can use called pow in the math library to do exponentiation, but there's nothing directly there. Some other things is that with division in Python, you can specify whether you want to do floating point division or if you want to do integer division, right? Single slash is floating point division, double slash okay. Oops, gotta do that to me every single time. But in C++, the type of division is dependent on the variables that are involved and what their types are. So in division, there's just one / operator, and whether you do integer division or whether you do floating point division is dependent on the types involved. If the types are all integer numbers, you will do integer division. If one or more of the, if like the numerator or the denominator is a floating point number, you will do floating point division. So be careful about that because it can mess you up. Mod is the same thing, but mod only works on integers in C++. It won't work on floating point numbers. So some examples. That's not supposed to be. Oh yeah. Never mind, take that back. So you can see on the left-hand side is what we would do in Python. Addition's the same, subtraction's the same, multiplication's the same. Division is a little bit different. If we do 3 divided by 4 in Python, we're gonna get 0.75. But if I want the same effect in C, I have to do 3.0 divided by 4.0. Or again, at least as long as one of them had a 0.0 after it to make it a double number, it would do the double division. So we could do 3 divided by 4.0 or 3.0 divided by 4, we'd also get 0.75 because at least one of the numbers in the numerator or denominator is a floating point number. If we do double division, right, we'd get integer division here. And in C++, because 3 and 4 are both integers, we just do integer division by default. Mod is the same. Exponentiation works in Python, but it's an error in C. Also be careful about something like this, which this was supposed to be 100.0. That's going to give you 0.0, because first we do 3 divided by 4. 3 divided by 4 is 0. 0 times 100.0 is 0.0. So watch out for that. Any questions? Okay. One thing to note is that all statements in C++ must end with a semicolon. It's really easy to forget this when you're first starting out, so pay attention. I know when I was programming for the first time, I forgot a semicolon on the end of every single line in my first program, and then the compiler whined at me that, oh, you forgot semicolons. I'm like, yeah, I guess I did forget semicolons. I had to go put them back in there. A statement in C++ is pretty much everything except for function definitions and control structures like for, while, if, switch. They don't have semicolons on them. So the basic variable types in C++ are int, short, char, double, float, and bool. The ones in bold are the ones that we're going to be using in this class. The ones that are not in bold are just there for your information purposes. So an int is used for whole numbers. A short can also be used for whole numbers. You can see that the main difference between an integer and a short is that a short is only 2 bytes big, whereas an integer could be 4 bytes big, right? You'd want to use the short if you knew your values would fit into this range and you were really concerned about saving space. It was a big issue. A character is used to represent a single character. You can also put numbers in it, like 5, and it'll be the number 5. So if you did decide to put numbers into it, you could do a number between -2 to the 7 to 2 to the 7 minus 1. A double and float are both used for real numbers. A double is twice as big as a float. That's why it's called a double. It's double in size, but it has a greater range of values that it can represent, as well as a greater precision between the values that it can represent. Because if you think about it, how many numbers are there in the real number scheme? How about just between 0 and 1? How many numbers are there? There's an infinite number of numbers, right? But if I only have 8 bytes, right, can I represent an infinite number of things with a finite number of things? No, right? So what's going to happen is some numbers aren't representable with doubles and floats, but doubles have more precision. So they're able to represent numbers that are closer together than a float would be able to. And bool is used to represent true and false. True and false are written in lowercase in C++, whereas in Python they would be uppercase. You had a question? So if you were curious on your particular machine how big a variable is, there's a function called size of. So you would do size of your variable, and it will tell you in bytes how big it is. Any other questions? Okay. One important thing to note in C++ is that characters are not strings. Strings and characters are 2 distinct types, and a character can only be used to hold a single character. A character literal is enclosed inside single quotes, whereas a string literal is enclosed inside double quotes. So if you had some char, say C, and you tried to make it equal to the letter A in double quotes, that's an error, right? It has to be single quotes for a character, double quotes for a string. You can, though, have strings that only contain a single character. That is valid. So watch out for this. It's a really common mistake to make when coming from Python.
So, letter A.
Like you compare them equals equals? No, they would not be the same. So the string A and the letter, it depends on the character A. It depends on how you compare them, because a string object can compare a character to see if it's equal, I believe. But a C string, which is what you would get if you have a string literal enclosed inside double quotes, is not the same thing as a string object, and that equality would not hold true. So it's a little like edge casey as to what exactly you want to do. So doing something like this, right? If we switch over to here, if I have something like, is the letter A right? Is this equal to the string A? That's never going to evaluate to be true. But if I had something like this, I need to include string to be able to use it because strings aren't a built-in type, as you saw before. You have to include string to be able to use string. If I have a string, come on, S that has the value A, and now I do like, is A equal to S? Oh. No, apparently you can't even compare string objects to characters. But this should yield true. No? Still? Okay, so this works, but the result's just not being used. So that would work. So strings have to be compared against strings. And even doing something like this, like comparing two C strings, I would not recommend doing this. It will not do what you think it does, but you can compare two string objects, which we'll get to what a string object is in a little bit. Wait till we get to the C portion of the class before we cover exactly what C strings are, but the quick definition is they're an array of characters that's terminated by the null character. Yeah, we'll get into more detail about this. There's just a lot of nuance in C and C++ that might, throw you coming from the Python environment. Just watch out. Yeah.
Is that the
C has no string objects. They only have C strings. Because C has no classes in it. But C++ does. Oh gosh. So here's how you do variable declarations, right? In Python, right, you just say A equals whatever, B equals whatever. And you don't list a type, and the type will be inferred based on whatever the assignment is. In C++, you have to declare the type of the object. So I have an integer A, I have a character B, I have a double C. I can also declare multiple variables on the same line. So here I've declared 3 different variables, D, E, and F, but only decided to initialize E. And then here I've declared 3 different doubles, G, H, and I, and I decided not to initialize any of them. You could not have an integer A and a double A in the same scope. A variable name has to be unique inside that scope. So again, in C++, you have to specify the type of a variable when creating it. Since that type is specified, it doesn't have to be given a value. But if you choose not to give it a value, what value it actually has is undefined, and it's compiler dependent. So you should never use this value. Some compilers will default this value to be 0. Others will leave it as whatever happens to be in memory at that location. So you'll see some random garbage value there, and that's what's going to be there. Before you use a variable, though, it must be initialized to something, right? So it might not start out as having any value, right? For example, like G, H, and I, that's fine. But before I use G, H, and I in the right-hand side of an expression, like doing addition or subtraction or multiplication on them, I better make sure that I set them equal to some value. Because if I don't, what happens? I don't know. It's literally undefined by the standards, and what happens is compiler dependent. You saw that multiple variables can be declared in the same line by separating each variable as a comma. You can choose to initialize some of them or none of them or all of them if you want to do that. And the rules for creating a valid variable name are the same as those in Python. You can have letters, underscores, and numbers, but you can't start with a number. Any questions before we soldier on? Yeah.
Our assignment also like D.
So if we wanted to so on the line where we have D, E, and F, if I wanted to make D equal to 5 and F equal to 12, I'd have to say int D equals 5, comma E equals 25, comma F equals whatever value you want it to be. No, so if you want to assign their values later on and just use the variables in the future, you do not re-specify their type. You only specify their type when you create the variable. So if I wanted to change A's value later on to be 10, I just say A equals 10, and that's it. Any other questions? Yes? So the question is it better to declare all the variables first and assign them later, or does it make sense to initialize their values to be something to begin with? I would say that I'm kind of bad in that if I know I'm going to like initialize a variable from like say the user input, I'm like, hey, please enter your age, and then I'm going to read in their age. I won't default their age to be something. But you will catch a lot more errors in your code if you choose to initialize all of your variables to some value to begin with. Because if you initialize it to some like funny number, probably not 0, like maybe negative 999, people probably aren't going to be entering that for their age, and something wrong happened and you saw, oh, the age was negative 999, you'd be able to figure out that somehow this variable didn't get set when it was supposed to be set for whatever reason. But I'm lazy and so I don't. Yes? Yeah, I just put single letters here to save space, but yes, your variable names can be whatever you want. And when we go through some examples in a little bit, you will see longer, more meaningful variable names. And of course, I would expect that none of you use single letter variable names in your code, except if you're doing like I for an index or J for an index. Or there's some really well-known like math letter you're using for this particular math equation. Everything else should be descriptive in terms of whatever the problem is. I've just made them short here to save space on the screen. Yeah. E would be 25. As you can see, D, comma, E equals 25, comma, F. So both D and F have an unknown value, but E is 25.
Oh.
Oh, okay. Good question. Apparently a lot of people were confused by that. Only E is being initialized here. D and F have no value. Or technically they have some value, I just don't know what it is. So keep asking the questions if you're confused by things, because you're going to be using this stuff a lot, and it's good to have the basics down before we move into more advanced concepts. Well, so first question, double is a real number, right? Like 35.27, 86.29, 0.34. So doubles are used to represent real numbers. No, you don't have to put F in front of E. This is legally valid, syntactically correct C++ code. I know it looks weird and you're like, why would you do that? To show you that you can, but it's not how I normally write my code. Any other questions? Yes. So on this line right here, I'm not assigning multiple variables, I'm declaring them. So I'm saying there is an int, or I'm making my variable declaration for types of int. So here I have an int D. That declares one variable named D. So comma, then we're also going to create an integer E whose value is 25, comma, another integer whose value is F. If we wanted to split that across multiple lines, which you certainly could, this is the same thing as doing int D, int E equals 25, int F. Can you declare the same, different types on the same line?
Yeah.
No. They'll have to be the same type. Any other questions? Yes. The type is not changeable after it's been created. So for the duration of that function or whatever that scope of that variable happens to be, it will always be that type. So A is going to be an integer, and it can't be anything else. Any other questions? Yes. So the question is, what happens if you assign 3.5 to a, given that a is an integer? What's going to happen is, you've probably done this before in Python, right? You cast floats to integers. And what happens when you cast a float to an integer? You do not get an error. Right? If we're over here and I do, right, I want the int of 3.5.
Oh, it just drops the 0.5.
Yeah, it just drops whatever comes after the decimal point. So if I had done that in that assignment, I would, oh gosh, I hate the fact that they use the zoom in as F5. If you don't hold control in the right spot, it'll kick you back out. So it would make a still be equal to 3, right? Or even if you said like a equals 3.999999, still 3. Any other questions? Yes. If the question is, if you enter a new scope, do you have to initialize the variable again? If you're entering a nested scope, no. If you wanted to declare a variable in that nested scope with the same name, and so it would hide the one in the outer scope, then yes, because you're creating a new variable, you would have to set it to some new value. It would not have the same value as the old one. Yes. You'll see scope in a little bit, but it's defined by the curly brackets. So one thing that you can do when you specify the type of a variable, you can use the keyword auto instead. If you choose to use auto, the compiler will attempt to figure out what the type of that variable is supposed to be, and it will replace auto with that type. This can be really useful when you have types that are extremely long, which we'll see a little bit later on, but probably not today. I don't like typing out like types that have like 20 characters in their names, so I'll probably use auto then. If you do use auto, that variable whose type is auto must be assigned some value, right? You can't just say auto x, because the compiler cannot figure out what the type of x is supposed to be. You also really want to make sure that you know what the type auto is going to be deduced to is going to be, what it's supposed to be, before you use it, because you can have some unexpected surprises if you're not 100% sure. Mostly this revolves around references or not references, but we'll see more about references later on in the class. So doing auto A, compiler can't figure out what the type of A is. It's not going to work. Also, just because you declare something as being auto doesn't mean its type is going to magically change between different things. The type will be figured out then, and it will only be that type. So if I have auto A equals 5, A's type is going to be an integer, right? And A is always going to be an integer, and it can't be anything else, even though I use the word auto there. If I do B, right, equals 5.0, auto is going to be deduced to be a double. If I do auto C equals a character, it's going to be a character. If I do auto D equals 3 divided by 5, well, what's 3 divided by 5? 3 is a integer, 5 is a integer, so after we do the division, we get an integer, right? Because integer divided by integer is integer, and so D's type will be an int, and so D will end up as having 0. But if we do, auto F equals 3 divided by 5.0, because at least, the numerator or the denominator is a double value, the type will be deduced to be double, and your answer would be 0.6. Questions on auto? Yes. No, it would never default to float over double, but you could be very explicit when declaring the literal that it was assigned to. For example, if you want it to be particularly a float, you could say like your number equals 3f or 3.0f, and that would be the value 3.0 as stored in a float. If you did 3.0 lf, it'd be a long float. So if you did want to float, you could do something like, auto g is equal to, 34.67 f. And this is auto goes to a float. And here, if you do auto age is equal to 34.67 at LF, it's guaranteed that auto is always going to go to a long float. Or to a double, my bad. So another name for a double is a long float. That's what the LF means. Any other questions? So function definitions. So here's some function definitions on the left-hand side in Python. And here would be their corresponding definitions on the right-hand side in C. One of the things that you're going to see in C++ is that you have to specify the return type, right? Because the compiler needs to know what the thing is that you're going to return, if you're going to return anything at all. You also need to specify the types of the variables that you'll be accepting. So over here, right, length needs to be a double and width needs to be a double. Integers are convertible to doubles. They're castable to doubles, which we'll talk about casting a bit later on. There's a lot of stuff just to get up and running. So you can pass integers to this function as well. If you want your function not to accept any arguments, you can leave it empty, like you can see here, and say hello. And if it doesn't return something, the return type is void. I don't actually return anything. Any questions from what you can see up here? Yeah. So I'll stop you there. You can't nest functions in C++. So you can't define a function inside of another function in C++. Which is, I think, what you were talking about, correct? Yeah, you can't do that. Yes. Mm-hmm. So over here, right, we're not initializing anything. I'm saying these functions accept values of type double, right? So when you call the function, say, rect area, you have to pass in something that represents a double. Like you can say rect area 3.5, comma 4.0, right? And then when that function gets called, length will be initialized to 3.5 and width to 4. Yes. Oh, you can totally call functions inside functions, right? You can even see that's happening right here inside try area. Try area called rect area, which I spelled incorrectly in this one. So this value over here on the left-hand side is the type that this function returns. So try area returns a double. Any other questions? Yes. So we'll get to that, but in C++, white space means absolutely nothing. Indentation means nothing. The curly brackets are what matters here, right? So the code that belongs to this function rect area is the code enclosed inside these curly brackets. The code that belongs to try area is the code enclosed inside these curly brackets. I still recommend that you do use good indentation because it makes it so much easier to read. But it's not necessary to compile syntactically. Technically, you could like write your entire program on a single line in C++, and it would compile and it would run and it would look like a nightmare, but it would work. Somebody over here, yes. We will get to that in a little bit, but std means the standard template library. And so we're saying I want to use the variable cout inside of the standard template library. And that's how you would print, which we'll talk about later on. Yes. So you are allowed to use underscore. In C++, though, the convention is to use camel case, like you're seeing here. But if you still like underscore, I will not hold it against you, and it will still work. Anything else? Okay. So the syntax in general for writing a function definition is the return type, whatever it's supposed to return, the name of your function, and then you list the type of each argument followed by the type of that argument's name. And then you have whatever code that you want to run when that function's called. Again, as was discussed, the curly brackets are what denote code blocks inside of C++. So anywhere you would be indenting in Python, you're going to be using curly brackets instead in C++. Again, good indentation is still really useful though because it makes your code easier to read.
No variable.
So the parentheses back here are say this is like my argument list is what's enclosed inside the parentheses, just like it was back over here in Python. Yeah. So the question is, can you call rect area with integers for its arguments? Yes, you can, because integers are convertible to doubles. So it would still work with any integers you wanted to use. Any other questions?
So after double knows that. So for the name of the function. Double.
I mean, like there does need to be a white space in between the name double and rect area, because otherwise it reads as double rect area, which is not a type. Right, so yes, there does need to be this white space right here to separate the double and the rect area. Yes, there does need to be a space between there, right? Because you can't, like, you couldn't distinguish where the word double was supposed to end and length is supposed to begin, right? If they're all squeezed together with no white space in between.
The white space.
I could say, maybe I should say, like, indentation does not matter. Might be a little bit more correct way of saying it. So like new lines and tabs don't matter, but white space does matter a little bit in that your like identifiers have to be separated by white space to be able to tell them apart. Yes. So the question is, can the return type of the function be different than that of the variables? Absolutely. Right? It just so happens here that if you're computing areas of doubles, you're probably going to end up with a double, right? But you could totally accept like a string and try to calculate its length and then return the length as an integer. No, you can't return more than one value. Good question for you is, can you return more than one value in Python? No. And you're like, what? I swear I've done that before. You've only returned a single thing, right? Because if you returned a tuple, right, a tuple is a single object that contains multiple other things. Or if you return a list, you return one list. That list just happens to have multiple things inside of it. So again, just like in Python and C++, you can only return a single thing, right? But we'll get to containers later on, and so you can definitely return a container that hold multiple values inside of it. If you want to give back a value from a function, it's still return. If your function's return type is void, you can just say return to leave the function, right? So as soon as you hit the return, you leave the function and you give back that value. If a function says it returns a value, it has to do one of these three things, because otherwise not doing so is undefined. And this means like in all cases. So like if you have like an if something return, right, and then else you don't return, that's an issue because you have to return something regardless of whether you go into the if statement or the else statement. So you have to either return something of the specified type, you have to throw an exception, which we'll talk about later, or you have to end the program by calling exit. One of those three things. Again, a function that doesn't return a value, its return type is void. If you want to call a function, calling a function is the exact same way you'd call it in Python. There's no difference. Function name, arguments, in parentheses, it works. Questions about this though? Yeah. No, so when you're passing in the arguments, you don't specify the types. The only time the types have to be specified is at the declaration stage, right? So when I'm declaring a variable or defining a function, or you'll see in a second, declaring a function, the types have to be specified then. But after the variable has been created, you don't say the type ever again. Yeah, you can see, right? Semicolons here at the end of these lines. If you don't do a semicolon here, you're going to get an error. Won't compile. Okay, so now there's one of these nice new distinctions that we need to make. It's between declarations and definitions. In Python, you can only define a function. That's why the keyword in front of each function is def. But in C++, you can both declare functions and define functions. What you've seen so far are function definitions, right? And that function definition is going to state the return type, the name, the arguments, as well as what code that you want to run, just like your Python definitions did. But a declaration states only the return type, the name, and the arguments to a function, right? This is going to give the compiler sufficient information so that it knows how to call that function and whether it's being called correctly. Also, if you declare a function, you are later promising somewhere down the line in your code that you will define the function as well. The reason that we need these declarations in C++ is that C++ is a top-down one-pass compiler. That means it starts at the very first line of code and works its way to the bottom, but it's only going to go through the code once. So by the time that code reaches the function call, it has to know how to call the function to be able to invoke it. So sometimes you might declare your functions in a different order, or you call your functions in a different order than they're defined in. And so you'd have to put the declarations at the top of the program to make it work. I will show you an example of this in 1 second. But my recommendation is that you declare every single function you ever create, and you put those declarations at the top of your program so that the compiler knows about all the functions that exist, and this will allow you to call them in any order. And again, I will show you guys an example of why this is important and how to screw it up in a second. So if you declare them first, right, you can call the functions in any order inside of any of your other functions. If you don't declare them first, you can only call them after they've been defined, and that's going to force your definition, or it's going to force the ordering of your definitions of your function to be in a certain order. Right? If you don't declare them all, you have to write them in a certain order for them to be able to work, which is really annoying. Yeah. Yeah, so in Python, right, you might have some function where you have def foo, right? And foo calls bar, but bar is not defined until down here, right? So notice your foo calls bar before the Python interpreter has seen bar, but that's not technically true, because when the Python interpreter goes through this, it says, oh, this is the definition for this function foo, and it goes and it translates it. Then it's like, oh, this is the definition bar down here, right? And so it goes and again, and it translates whatever this code happens to be. And then down here, you might have something where you actually call foo. So this is now fine because both foo and bar have been defined. But if you tried to stick this here, it's going to break because bar doesn't exist yet. But it's different with C++ because it's because it's being compiled and not interpreted. And so doing that translation has to happen all at once. But you'll see what this looks like and how to do it and why it makes your life a little bit easier in 1 second. So the syntax for making a function declaration is return type, function name, argument 1 type, argument 1 name, argument 2 type, argument 2 name. So it looks exactly like the function definition, except there's no code body. You just end it with a semicolon instead, right? This rect area, try area, and say hello, they look exactly like the beginning of the function definitions on a few slides prior, but notice there's no body to go with them. There's no code to run. We're just saying these things are going to exist. So, is this big enough, or do you guys need it bigger? Anybody need it bigger? Okay, got one person. Okay, well, we'll pump it up to 24. That big enough? I guess so. Okay, so you can see here that at the top of my function, or at the top of my program, I've made the declarations for my functions. You can also use the keyword auto for the return type of a function. But auto always has to be deduced to the same type. So if you have an if statement, it's if x equals 5, return 3, right? else if x equals 7, return hello. That's not going to fly, right? Because one time you're returning a string and the other time you're returning an integer. It always has to be the same consistent type. So down here later on, right, trap area is going to return a double. So this type has been deduced to be a double. And again, like these functions aren't very interesting. You can see that trap area, we calculate the rectangular area of the trapezoid, and then we calculate the triangular area of the trapezoid, and there are 2 triangles and 1 rectangle in a trapezoid. Agreed? One rectangle, 2 triangles, right? This rectangle right here, it's a short side by short side on this dimension. This is the height here. What's left over here for the triangles is the long side minus the short side, and then split over 2 triangles, so divide by 2. Right? And like calculating the triangle area and the rectangle area, right? Nothing complicated there. So what would happen if I took these declarations out and commented it out? This is now going to cause problems because imagine you're the compiler, right? You're going top down from the bottom, and you can only do things that you know about. So I get down to rect area, and I'm like, what the heck is rect area? Have you seen anything about rect area? Do you know what that is? Do you know how to call it? Do you know how it should be called? How many arguments it takes? What it returns? No, and so the compiler's like, yeah, I got that same issue here too. I don't know what to do, and so it complains at you. If we wanted to make this work without doing any of the declarations at the top, notice that rect area doesn't depend on any of them. So rect area would have to be moved to the top, right? But since trap area depends on both rect area and tri area would have to also go before the trapezoid area. And then I have to make the tri area go after the rect area. So it would force me to define these functions in this way, which I find that personally to be extremely annoying. I feel like I should be able to define a function whenever I feel like, right, in whatever order, which is why I do the declarations at the top. Because the compiler knows about the declarations at the beginning, you can then say, okay, later on I can create those functions in whatever order I choose to. And if you're curious about how did Matthew make all those lines commented really fast, it's Control/ inside CLion. Takes them out. Control Shift/ makes it a multi-line comment. Any questions about the declarations versus definitions? Okay. Yeah, I only declared 3 functions, and I defined all 3 of those functions. Later on, doing something like this, like forgetting to define rect area, that's an error. Because you've promised to the compiler to create some function that's called rect area that returns a double and takes 2 doubles of arguments, but you didn't. And so if I press the build button to try to compile my program, we are going to get some error that's like, hey, scroll up. In function trap area, we have an undefined reference to rect area, which means I didn't implement that function. So if you see an undefined reference to something, it means you probably didn't implement the function. Any other questions? Okay. We'll go back to that example in a minute. But C++ also supports optional arguments as well as Python does.
Body was.
Yes. The body of each of these functions is inside these curly brackets. Yeah, this is where the definition is, right? So whenever you call trap area, this is the code that's going to be run inside these curly brackets. Wherever you call try area, the code inside these curly brackets will be run. Right? The indentation does not matter, but I think it makes it look a lot better. How many of you guys have used optional arguments or declared a function that had optional arguments in Python? Oh, God. Okay. So you can do that if you didn't know that. If a function has both a declaration and a definition, the optional arguments are only specified in the declaration. If you want to do this in Python when you define a function, list your variable and say it equals some value. And then if you call a function and you don't give that variable, it'll be substituted with the default value. You must list all required arguments before any of your optional arguments. Right? As an example, if you want to see this over here in Python, right, I could def some function, right, a comma b equals 3, c equals 4. And I can just say like print a, b, c. So now when I call this function, I have to pass in at least one argument, a. So maybe 7. The other ones get substituted in with their optional arguments, 3 and 4. If I do fun and I want to do it with 3 values, I could say, you know, something like 10 and 15. And now both a and b have a different value specified. So we'll print 10, 15, and 4. One of the cool things that you can do in Python is, again, I still have to give a, but let's say I don't want to give b. I can just say c is equal to like 24, and b will be given its default value. So I can specify only some of the optional ones. Other crazy things that you can do would be something like, you know, c equals 89, a equals 23, and b equals 5. I don't know why you would specify them out of order, but if you list them by their names, you can in Python. It works. So now you know a little bit more about Python and optional arguments. In C++, you declare them the exact same way. So these voids should be lowercase. So we have a, which is again required, b defaults to 2, and c defaults to 3. Notice that since I've done a declaration and a definition, I only do the optional arguments in the declaration. The definition just looks like a, b, and c are all required, but they aren't. And over here, all I'm doing is printing out the values with a comma in between them. So if we do like, you know, 7 here, that means a gets 7, b and c are still 2 and 3. If we do 1 and 10, a is 1, b is 10, c still defaults to 3. If we try to use that cool little syntax trick, right, because we don't want to do the ones in the middle, it doesn't work in C. You got to specify the ones in between. So you'd have to say, you know, a is defined to be 5, b, give it its default value, which is 2 in this case, and then c, we give the 25. Any questions here? Yes? So if you only define the function and didn't give the declaration, the default values would be placed inside the declaration. Any other questions? So if a declaration and a definition are given, the default values are only placed in the declaration. If only a definition is given, the default values would be placed in the definition. Anything else? So, function uniqueness. In Python, functions have to have a unique name, right? If you define a function with the same name in Python, what happens? Or, well, I guess I can just do it over here. If I do like def foo, and then I say, you know, print 10, and then I do def foo, and then I say print 17, and I call foo, what's going to happen? It's going to print 17 because I replaced the definition of foo, the first definition of foo, with the second definition of foo, which sometimes you might accidentally do if you like, you might accidentally override like a default variable that you didn't know was a default variable or had a default function name. I got 1 minute. So, in C++, functions don't have to have unique names. They have to have unique signatures. A signature is made up of your return type, the number of arguments, the name of the function, and the types of the arguments. If the function's signature is unique, you're cool. Writing a function that has multiple that has the same name but different arguments, different signatures. It's called overloading the function. I will show you more of this on Friday. Right? We're not even programming yet. It's scary.